I know I took a break from the videos. I needed to regroup a little bit. Hopefully this one's a little bit better. But today we're going to be talking about equations of circles on a coordinate grid. It's kind of cool being able to do this, and we're actually going to see stuff from chapter 1 that we haven't seen in a while, which is really neat, which I know how much you guys love that, haha. So, again, we're going to be talking about putting these on a coordinate grid, so you're thinking of your x, y axis, all that good stuff, okay? So, when we're writing equations of circles, the major thing that we need to know are the center point, as well as our radius. Those are going to be the two things that we definitely need to know before we write our equation, okay? So, in order to find our center point, we're going to be using the letters H as well as K, okay? That's going to be the two letters that we use. H is going to represent our x value, and K is going to represent our y, okay? So if you think about an ordered pair, H comma K, that should be your x comma y of your center point of your circle, okay? Your radius, which you're going to love this, I know you will. In order to find your radius, you're actually using an application of your distance formula. I know all of you are cheering at home. Woo! Ha. So, you're using your distance formula to find your radius. Actually, the equation of a circle is kind of like an application of our distance formula. So hopefully this helps you out a little bit when it comes to using your formula sheet for your SOL, okay? So, your equation of a circle, the general formula, I'm just talking about the general formula, is going to be x minus h squared plus y minus k squared is equal to the radius squared, okay? So that's going to be the formula that we use whenever we're writing our circles, okay? So, again, what did we just talk about? H was going to represent what again? Yeah, the x value of my center. And K is going to represent the y value. Good. And our radius, again, think back to that first video that we talked about all of our definitions. Radius was going to be what? Half of the diameter. Good. So from the center point out to one edge of our circle. Okay? So, moving right along. Write the standard equation of a circle with the center at -4, 0 and radius of 6. So let's write down our general formula and see if we can start plugging stuff in. X minus h squared plus y minus k squared is equal to radius squared. Okay, so what were we given in this formula? You were giving our center point. Let's label that center at -4, 0. We're also given a radius, good. And our radius, or r, is equal to 7. So, what can we do to find or to write our equation? Because that's all they're asking for us is to write the equation. Yep, let's start plugging stuff in and see what it looks like. So, again, -4, where am I plugging -4 in? Yeah, that's going to be my h. And 0 is going to be my k. So let's plug those in. So I've got x minus a -4 squared plus y minus 0 squared equals r. What was r again? Yeah, it was 7. But we have to make sure that we square it because it's supposed to be r squared, not just r. So I'm thinking 7 squared. Let's clean that up a little bit, see what it looks like. So, what do you guys remember about two negatives? Yeah, it should make a positive. So instead of being x minus -4, it should be x plus 4. Good. Plus Well, y minus 0. Yeah, it's just equal to y. So do I need that minus 0? Nah. So I can write it as y squared is equal to, what is 7 squared? 49. Good. So there is my general equation of my circle. Okay? Again, if you have questions on any of this, make sure you're jotting them down on your notes. Here's your practice. Go ahead and try it on your own. Again, if you have questions, make sure you're writing them down, but do give it a try. Know you can do it. Example 2. So for this one, what did they give us? Well, I see a center. Good. But did they give us a radius? No. This is going to be tricky. So let's write out what information we were given. So I know that the general formula was x minus h squared plus y minus k squared is equal to r squared. I know my center is 5, negative 1. But they also give me a point on the circle. Okay. Curious. So, if I know that this is my circle, they gave me my center point, which was at 5, negative 1. And they gave me this other random point out on there. Somewhere. I don't know. I just drew there. Okay? And they want us to write it in that standard form. How could I potentially find that radius? Right. So let's plug in my center point in for h and k, because we already know how to do that from the last example. So 5 is going to be plugged in for h, negative 1 is going to be plugged in for k. Let's plug that in. So I've got 8x minus 5 squared plus y minus a negative 1, which is plus 1, good, squared is equal to r squared. Okay. So I want to find my radius. So what do you think I could do with this other point? Hopefully you're saying plug it in for x and y, and then see if we could solve for r. Give it a whirl. So let's plug 1 in for x, 2 in for y, since our ordered pairs are always x comma y. We're plugging 1 in for x up here, so we've got 1 minus 5 squared plus plugging 2 in for y, so 2 plus 1 squared is equal to radius squared. Now, this is usually where things get a little confusing, just because sometimes people plug in the point in for h and k and the center in for x and y. Make sure you plug in your center first. That's why I wrote this equation first before I plugged in my point. That should work, okay? So make sure you're careful with that. So from here, I want to simplify this, okay? What am I going to use to help simplify this really big mess? Order of operations, good. So I have to look at whatever's inside my parentheses first. So I'm doing 1 minus 5, which is negative 4. And 2 plus 1 is 3. Good. Oops. So I've got negative 4 squared plus 3 squared is going to equal r squared. Good. So from here, what do I do next? Yeah, so I have to do my exponents next. So negative 4 squared, so negative 4 times negative 4 is positive 16. Good, because you said negative 16, oh my goodness. 3 squared, 9, good, is equal to r squared. Now, hopefully you're seeing this. This should look kind of like something we've talked about a lot this year. Yeah, it kind of reminded me of Pythagorean theorem, right? From here, you've got a squared, b squared, c squared. Kind of cool. Anyways, sorry, tangent. So, next thing I'm doing down here, add them together. So that's 25 is equal to r squared. So my last step, I want to get r by itself. How do I get rid of that exponent? Good. Opposite of squaring is square rooting. So I square root both sides. So r is equal to 5. Am I done? Not quite. They wanted us to write the equation of the circle. So what do I need to do with this r? Yeah, I need to plug it back into my original equation, not the one that has the point plugged in. That's where usually there's a lot of issues. So make sure you're plugging r into your original equation right here, and you're using the rest of this exactly how it is. So my answer should be x minus 5 squared plus y plus 1 squared is equal to 5 squared, which that can be rewritten as 25. So I'm going to do that right now. If you wanted to, you could have made a whole other step of you plugging that r in. That would be awesome if you did that on the test. You would probably, if you did some sort of math mistake, you would not get docked as many points if you showed that step. But that's fine if you don't. Your choice. So there's your equation. That's if you were given a point and your center point and not a radius. Okay? So here's your practice problem. Go ahead and try it on your own. Try your best on it. I know you can do it. If it's blank, I'm probably not going to give you points for your homework, but make sure you're giving it a whirl, okay? Worst thing that can happen is you erase it. All right. So, example 3, let's talk about graphing them. And it's actually really cool how we get to graph these, okay? So, I'm given an equation of x plus 2 squared plus y minus 3 squared is equal to 9 squared. So, again, thinking back to my original basis of this formula, that was x minus h squared plus y minus k squared is equal to r squared. Well, again, h and k, what did they represent again? Yeah, my center point. So, again, my center should be h and k, and r represented my radius. Good. But again, the thing to be careful about is this is r squared. Something to think about. So, easy part's probably going to be picking out your center point. So if I were to looking at this equation up here, and my general equation, what's different about it? Yeah, I've got a plus instead of a minus, okay? Things to be careful of. So, is my h going to just be 2? No, it's going to be negative 2. And the reason for that is because of the previous example that we talked about before. When we had, this one here, when we had 2 negatives, it made this a positive, okay? So we're kind of working backwards. If we've got a positive, we have to think of splitting it up into 2 negatives, okay? So let's do exactly that. I've got x minus a negative 2 squared plus y minus 3 squared is equal to 9. Okay, so my center point should be fairly easy now to figure out. Negative 2, 3. So there's my center. Okay. Again, as you get used to this, you're not going to have to do this splitting up method, but just so you guys can see where that plus came from, okay? Next part is finding our radius. Well, again, in my general formula, it was r squared. What is equal to r squared right now? Yeah, 9. So 9 is going to be equal to r squared, but I just want to find my radius all by itself. So what would I do to get rid of that exponent? Hopefully you're saying square rooting. Square root both sides. R is equal to what? Yeah, it's equal to 3. So I've got my radius, I've got my center. These two things are going to be my key things in order to help me graph, okay? So, first thing, let's plot our center. Sorry, I was in your way. Negative 2, 3, and 3. So my center, again, was negative 2, 3, so let's plot that point. So negative 2, comma, 3, whoops, upward. So there's my center point. Let's make it C, just for fun. And my radius is 3. So what do I know about a radius? It's the distance from the center out to the edge of my circle. So if I wanted to, I could count out 3 units in each direction. So up, to the left, down, and to the right. And again, these are all from starting at my center point. And I know it's a little hard to see. Let me make this a different color. So all I did was counted these out 3 spots out in each direction in all 4 directions. So up, down, or left, right, down. Okay? That should be my radius, 3 units. And all I'm going to do, and I'm going to try my best to make a pretty circle. Oh God, we're definitely not. There's my circle. Okay? So that's how you graph a circle. Again, you could kind of check your work to make sure that you did it okay. You could check, is my center at negative 2, 3? Yep. Is my radius 3? I could count out. 1, 2, 3. Yep, I've got both of those things. I'm checked away. This is an excellent circle, even though it's really poorly drawn. Okay? Again, if you have questions, jot them down somewhere, okay? Otherwise, I would still like you to give this a try. You should be able to do it. It's really not that bad, okay? I know you can do it. I know you can do it. Okay? Again, there's another practice, actually. I forgot that I put this on here. But this one's kind of like that tricky one that we talked about before we graphed them. Just talking about, what if I'm given a point? How do I write the equation? Okay? Last example, example 4. This one's kind of an application. It's kind of a little interesting. So, bank of lights is arranged over a stage. Each light illuminates a circular area on the stage. Circular. I wonder where that's going to come into play. A coordinate plane is used to arrange the lights using the corner of the stage as origin. So the corner of the stage as the origin. The equation, x minus 13 squared plus y minus 4 squared is equal to 16, represents one of the discs of light. Graph the disc of light. 3 actors are looking at the following. Which actors are in the disc of light? Okay, so first thing I messed up on was my scale. I am so sorry. So let's change the scale on my graph. Let's make it counting by 12. Let's make it counting by 4. So each line will be actually 2. So 2, 4, 6, 8, 10, 12. Yeah, that'll be okay. It'll just be a little off. Okay? So again, same thing. 2, 4, 6, 8, 10, 12. Okay? And again, same thing with these. This would be negative 12, negative 10, negative 8, negative 6, so on. Okay? They want us to graph that equation first. So again, let's do what we did last time in that last example problem and see if we can figure this out. So our equation was x minus 13 squared plus y minus 4 squared is equal to 16. So again, let's find my center, let's find my radius. Okay? So my center, I'm going to make it C. Oops. My center would be 13, 4, good. 13 was my H, 4 was my K. And what was my radius? How did I find that? Well, I know that this is equal to radius squared, So r squared is equal to 16. How would I find radius? Square root. Good. So r is equal to 4. Let's go ahead and plot that point. And again, even this scale, I did not make it quite as well as I want it to be, basically. Okay. So let's graph these. So I've got 13, 4 as my center. Let's do that. 13, 4. Ooh, good thing I made an even number. And I know that my radius has to be 4, so I need to go 4 in each direction. Wow, I really messed up on this scale. So this was a 14. So I need to go 4 in each direction again because of that scale. Oof, that gets really messy. So I go 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Sorry about that. My circles are so bad. Next thing, so we've got our disk of light, check, we did that first part. Next part is they want to find out which people are located in that light, and they gave us the coordinates for each person, okay? So where are we looking for these people to be standing? Yeah, inside the circle. So we need to figure out which ones are actually inside of our circle when we plot them. So our first person, Henry, is at 11, 4. So is that Henry inside my circle? Yeah, right in the middle, front and center. So he's a yes. Jolene, sorry, is at 8, 5. What do you think? Yeah, she's way outside. Sorry, Jolene, you don't get that spotlight. And Martin is at 15, 5. So 15, and then 5, right here-ish. So, Martin, is he in the light? Yeah, he is. So Henry and Martin are good. Jolene, sorry. Probably because that song is terrible. Okay? So again, try those practice problems that I gave to you. We're going to do a little bit more word problem-y kind of stuff in our gallery walk when you come back into class, as well as some more practice. Okay? All right? See you next time.